And we are back looking at the daily space weather. Looking at the sun on 193 angstroms here. Coronal hole just moving out of the Earth-facing region there. Another one moving into the Earth-facing region there, north of the equator. But more importantly, let's check out the colorized magnetogram, as there is tons of stuff to cover. Possible sunspot forming, as well as some anomalies showing up in the solar wind stream. Also a coronal mass ejection that nobody seemed to see except us, although NOAA is finally talking about it. Let's check out the colorized magnetogram here. That area there could be forming into a sunspot. This area down here is certainly cycle 25-ish. So that's some interesting stuff. And also a little bit of activity rising over here. This is an area to watch right here, just south of the equator. And let's look at more stuff, as there's a ton of stuff to cover. Here's the coronal mass ejection that we showed you yesterday. If you watched our videos, you probably saw this before anybody else. And let's just rock this back to where it occurred right there. About 3 o'clock Universal Time yesterday. And this is an Earth-facing coronal mass ejection, folks. It is Earth-facing. We'll look at it on the LASCO C3 in a minute. And here's the LASCO C3 image. We're going to look at the GOES X-ray imager also in a moment. And you can see right around... Hang on a minute, let's let that play again. Right around this area, you can see some plasma incoming on both sides. Maybe you can't see that. It's pretty diffuse. It's not the kind of thing that's going to cause any major geomagnetic storms. But we cover it because everything is a dry run for everything else, folks. Here's a GOES X-ray imager. And again, we see this active region down here. Like a little activity kicking up there. If you're going to see a sunspot form, that's the most likely place for it to be. Second most likely is down here at a very high latitude, close to the South Pole. And there's a little bit of activity over here also on the eastern limb. We're going to look at more views of the sun, but there's a lot of other stuff to cover, so let's keep this thing moving. Check out the auroras that are sparked. Keep in mind at the equinoxes, the Earth's tilt is the optimal mode for maximum auroras, and we typically see these, around the equinoxes. 10.7 centimeter radial flux at 67 currently, so solar minimum conditions as far as that goes. But lots of stuff kicking off. Now, thanks patrons for being associate producers of the channel. We appreciate your patronage, as you are keeping us afloat, unlike YouTube and Google, who shakes us down for money instead of paying us for our content. You can also support the channel via PayPal donations if you like, or if you're in the market for CBDs, check out the links below the video to the Hemp Lucid Spaced Out campaign, specifically formulated for our spaced out viewers. Let's talk prepping. David Dubine's book, Climate Revolution. Now, we're cited in this book, and we're going over a little tidbit of it every day as a teaser. Hopefully, we're not giving out too much information. David, hit us up on Skype. By the way, viewers, we're going to be making some more videos. We're on a mini vacation right now from, quote, work, end quote. Our job. I'm on vacation from my job. And if I sound vague about what I do, that's because I don't have time to explain. Anyway, step number 8, which is where we are now, eat healthy, become physically fit, and sleep well. Sounds like a pretty basic thing to do as far as prepping goes, right? But it's super important. So get on it if you haven't already. Now, like one major change that we've recently made is just simply switching to organic coffee. Now, he's talking about committing to a plant-based, low-sugar, low-manufactured fat diet. Plant-based, I eat meat, so as far as plant-based, I don't care about that. Now, I practice a modified ketogenic diet because as a pro cyclist, I have to eat a bunch of carbs. Otherwise, I can't get that high-intensity energy. However, if I'm in a mode where I'm not doing a lot of riding, I go into basically a ketogenic mode, and I do intermittent fasting practically every day. It's made huge differences in my health and smAsho staff's health. By the way, shout out smAsho staff. We're going to be making that map of the website soon so that you can modify that for us. Anyway, again, the book by David Dubine, Climate Revolution, is available at oilseedcrops.org. And we've got links to that below the video as well. Climate Revolution book. Shout out, David. Looking for a Skype call soon, maybe today. Let's talk about more prepping. How about archive.org with the U.S. Military Manual Collection? You want combat skills of the soldier, you want booby traps, you want special forces medical, you want sniper training, you want all of the manuals. Ranger Handbook, updated last in the year 2000. We got links to that too. If you're into prepping, go download all the manuals and read all the manuals. Put them on a thumb drive. Put them in a Faraday cage. If you're wondering who the cavalry is, folks, it's probably because you're the cavalry. You're the cavalry. De oppresso liber. And we're on the real-time solar wind now. We see this wobbly shift in the phi angle here, going from near 360 back to 0, back to near 360, back to 0. That's the angle of the incoming plasma, folks. That's the magnetic orientation of the incoming plasma. And this gets oriented based on magnetic fields, and you can see it's all over the place. The BTBZ is all over the place. And we see this sputtering solar wind coming in right now. That could be a coronal mass ejection. We don't see a precipitous drop-off of the solar wind density there. We see it's ongoing here in between about 5 and about 7 protons per cubic centimeter. And the solar wind speed, it's just kicked up at the same time. That could be another one of these diffuse coronal mass ejections. Current solar wind speed, 357 kilometers per second. There's the data from ACE. KP index is at 2. That's the planetary K index, folks. Next, we'll look at the magnetosphere movies here. University of Michigan geospace model. And that is my cue to talk about things that are there and aren't there. Just kidding, folks. Anyway, here's the velocity. We'll let this play through so you get 4 hours of data. Keep in mind, low velocity is red and high velocity is blue. Here's the density. Low density showing as white, high density showing as blue. And we're looking at magnetohydrodynamics here, folks. A new, well, I shouldn't say new, but a burgeoningly important branch of science that is going to be more and more important because it governs things like cosmology. Anyway, there's the density, and here's the pressure. We do see some, you can see the shifting of the phi angle actually represented there. If you look at the magnetotail side on the equatorial plane view, you can see it kind of shifting up and down a bit. That's the phi angle shifting back and forth. It doesn't happen instantaneously. Here, let me show you right here. You see the way it's... Let me pause it there and break out the Epic pen. The way it's shifting right here. See that shift? That's the phi angle shift right there, folks. Anyway, let's move on to the ground geospace magnetic perturbations here. As people are rather interested in what the geomagnetic poles are doing, what with the massive polar excursion going on, and all kinds of scams out there on the internet trying to collect money from people to collect redundant data or collect no data whatsoever. You know who you are. I don't know if you know who you are. You're probably not watching our video. And for that, we thank you. Anyway, there's the ground geospace magnetic perturbations. I want to announce a change in the ionosphere movies, as this is a fairly new segment to begin with. We're going to raise the resolution of this before your very eyes. So we're going to keep looking at the last 6 hours, and what we've been viewing on this ionosphere movie view here, courtesy Australian Government Bureau of Meteorology. What we've been viewing here is 1 hour per second, and we're going to switch this to 15 minutes per second for maximum resolution and reload. And I just want to announce that because that's going to be the new view, and I don't want anybody to be confused about what we're looking at. We're still looking at the same data here, just 4 times as many images. So still the last 6 hours, but 15 minutes per second here instead of 1 hour per second. We actually see a quite highly charged ionosphere on the daytime side and a quite highly discharged ionosphere on the nighttime side. Check out the latest image. Yeah, we're already at 11 megahertz there. And the South Atlantic anomaly is acting anomalous. Shout out Anomalous Howard. How's your ranching going? Did you buy silver when it was 14 bucks an ounce and we told the channel viewers to buy silver? We do see some changes in the X-ray flux happening here. No real surprise there, as there are some active regions facing the Earth. Here's a GOES electron flux. We would not be surprised to see a dip in this at all. That would be completely predictable. And the relativistic electrons are kind of in a nominal range here. Nothing too exciting there. Charging hazards are pretty minimal, and they're over Central America, Northern South America, etc. Here's where stuff is in the solar system, and we've got some interesting stories that we're going to cover in this video before we even produce a second censored versus sinkhole video. There's where stuff is in the solar system. And there's where things will be in 1 week, just a few hours from new moon. By the way, we're going to be going back to live streaming soon, folks. We prefer to live stream. We've only stopped because of software. So look at that coming back. And we're going to be live streaming for the equinox, which is on Monday around 3:50 a.m. That's 3:50 a.m. Eastern Daylight Time. That's New York time, by the way. Check this out. You want to hear something really crazy? Are you familiar with Enceladus? Well, Enceladus is producing geysers that are so big that they're causing it to snow on other Saturnian moons. So, this is an image of one of Enceladus's geysers here. And it turns out that these geysers are causing the albedo of Mimas and Tethys, the 2 neighboring moons to Enceladus, to increase their albedo. It's snowing on Enceladus, a moon similar in size to the Earth's, and it's snowing onto these other neighboring moons. The Saturn ring system is one heck of a weird place. There's Tethys and Mimas, which actually look a little bit like the Martian moon Phobos, right? See these obvious giant craters. Each one has a dominant crater and looks like the Death Star. The way they have this raised area in the middle of a crater. Does that look like an impact crater to you folks? Please leave a comment if you've studied electric discharge theory versus impact or crater theory. Where did they come from? How could it happen like that? How could these things form? Are these just giant beads that are forming as a result of electrical discharge? Please leave a comment. How about Venus? Well, Venus is one weird place, and Venus flies in the face of gravitational accretion theory. Venus is a strange place. Venus's day and year are about the same length. So it takes almost an entire year for the planet to rotate one orbit. So basically it has a nighttime and a day side. It has a night side and a day side. And it turns out that on the night side, the clouds move toward the equator. And on the daytime, the day side, the clouds move toward the poles. Electric universe much? This is all caused by the fact that Venus's atmosphere, just like Earth's atmosphere, is a semiconductor, and so there's a massive charge disparity from night to day, and it totally affects the way the current goes through the planet. And yeah, read the article. There's links in the description of this as well as every other thing that we visited. And let's go back to space. Other space. Local space. How about the GOES magnetometer? We're seeing variations in it as some plasma's hitting, and there's some activity going on the far side of the sun, just opposite the Earth. Check out the last frame here. You see that green streak there? That's the north solar polar field taking over the current sheet in that area. Probably an indication that a sunspot has formed south of the solar equator in that area. Now we'll be watching this for the next days, as this is the only way we have any idea of what's going on the other side of the sun. We can't see it at all. Now, we can see it from stereo A. Stereo B has been compromised since 2014. Keep in mind, this data is actually 1 hour and 45 minutes old. And keep in mind that magnetic environments can change with absolutely no warning. Here's where stuff is above my head, and pardon the lateness of the video, folks. Again, there's going to be more content coming out in the next couple of days. The moon is near its apex. Where were you when Deneb rose? Earthquake rundown. Just about 24 hours ago, we see a 5.3 at Tonga, followed by a 5.1 at Tonga. It looks like the deep quakes have chilled out for a while, folks, but everybody should still remain on alert, as there's another coronal hole moving into the Earth-facing region. Here's a 4.4 at El Salvador. That one not at depth either, a 4.5 at Chile, Western South America, and Oceania. Those are the places where I would expect to see a big quake soon, as there's a massive 6 and 7 earthquake drought. 4.7 at the Philippines is the next on the list, followed by a 5.4 at Vanuatu. I think that might have been the largest quake of the past 24. Followed by a deep quake at a 4.6 magnitude, 518 kilometers depth at Fiji. 5.0 in Indonesia, 4.6 in Indonesia. That one occurring just before UT midnight. 4.6 in Indonesia. Here's a deep quake at Chile. That one 98.3 kilometers depth. 4.8 at Mongolia. We have been seeing quakes in that region of China recently. A 4.7 at the Philippines. A 4.1 at Chile. Moving on to the volcano rundown. Shivaluch exploded. Produced a 15,000-foot ash plume, Mount Aso. Don't be an Aso and try to jump over Mount Aso, as there's possible continued activity, but they can't see the cloud because they use a satellite for it. Sakurajima exploded. Produced a 9,000-foot plume. Tokono exploded. 7,000-foot plume there. Popocatépetl exploding. 22,000-foot plume there. Revenador. Explosive activity continues there. 14,000-foot plume. And please don't fly your John Denver-style ultralight over Sabancaya. You may be less identifiable than John Denver as it's producing a 26,000-foot ash plume. Here's the windy.com pressure maps. We'll let this advance 24 hours and then we'll move on with our lives. If I can get the play button to actually do anything. Out of the way, Epic Pen. All right, there we go. Just going to let that advance 24 hours here. And we're going to hit pause so everybody can see where the pressure zones are. And that's about 24 hours from when we're making the video. Again, we are going to start streaming live again, folks, so be prepared. Here's a U.S. Doppler radar. We see the Dakotas. The Dakotas in Minnesota are curtailing walleye fishing, as well as a bunch of stuff. It looks like some snow falling in places like Wyoming and Montana. Yep, there's some snow on the radar, folks. Now, summer ends Monday morning at about 3:50 a.m. Again, we'll be streaming live for it. Look at those nasty storms. South Dakota and northwestern Minnesota getting hammered. Getting hammered as hard as Plankton's computer on SpongeBob SquarePants. Known as Karen 2.0, if you were wondering. Anyway, a long band of lightning going on there. Let's look at the NASA GOES interactive weather satellites. Actually, scratch that. Let's look at null school first. We're looking at the 10 hectopascal winds, and we're seeing spring happening in Antarctica. Spring in Antarctica, folks. As the vorticity changes, we start to see vorticity forming in the northern hemisphere also. See that counter rotation? It looks like almost like a spiral galaxy with two spiral arms. The 10 hectopascal wind, the upper level ultra high pressure winds. Anyway, here are the extremely meridional jet stream flows here. This is flight level 25,000. You can see northern hemisphere convective patterns still running the show, as well as 180-degree bends in the jet stream. Check that one out. Over the North Atlantic there. A 180-degree bend in the jet stream. Extreme meridional jet stream flow. And doubled up jet streams, the same thing we've been seeing for pretty much the entire solar minimum. Anyway, let's look at it from the equatorial view here. There's the western jet streams. Excuse me. And there are the eastern jet streams. Moving on to those NASA GOES interactive weather satellites. And here's a NASA GOES shortwave. See a strong convergence line there going across Mexico. And let's zoom in on that area there over the Dakotas. There's that pretty violent looking system there, moving at hypersonic speeds across South Dakota. Let's look at the water vapor map. And there's a water vapor map view. You can see obviously a heavy convergence going on associated with that dry mass of air, as well as a bunch of parallel lines there. Parallel lines. It's not a coincidence, folks. It's not chemtrails. It's not contrails. And it's not caused by CO2. Also, some interesting water vapor patterns here over Missouri. And let's look at one other view here. This is another tropical system out here in the Caribbean. Really, it's two tropical systems out in the Caribbean. And I just wanted to give you a view of that. What an interesting Earth spot that is. And we'll leave you in suspense as to what's going to happen with that next, as I don't have any idea, and I'm not willing to find out. Second video coming out soon, so don't forget to watch that. And stay tuned for one bonus feature, just one. Actually, we're going to have to make it two, because here's the sun, 304 angstroms. This is 8.5 hours. And we see this filament is actually remaining pretty steady. But check out this eruption over here on the west. That just came out of nowhere, folks. Let me migrate. And there's that sudden prominence there, right on the setting western limb. And we're going to give you one more view. You can see this a little bit also at 171 angstroms, located right near my pointer there. Let's zoom out. And there's 8.5 hours at 171 angstroms. Thanks for tuning in, everybody. Again, probably 2 more videos coming out today. At least one, though, as there's still quite a bit of stuff to cover. Keep an eye on this region right here. Let me point to them. This region right here, as well as this region right here. And there's even some stuff going on here. So, thanks again for tuning in. Thanks, patrons. Please don't forget to like and subscribe if you enjoy the content of the channel. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your veins.